Sometime back in my AI services company Atlic Technologies, we built a log classification system for our US based client. The problem was complex, so we had to use hybrid classification system where for fixed patterns we use regular expressions in Python. For complex patterns where we had enough training samples, we used BERT encoding and logistic regression. And for complex patterns where we didn't have enough training samples, we used LLM. In this video, I'm going to build that exact same project in front of you. For obvious reasons, we are going to use synthetic dataset and the problem domain is changed a little bit, but the technical architecture and approach is exactly the same. In terms of tech stack, we will be using Deepseek R1 or Llama, BERT, logistic regression in scikit-learn, Python regular expressions, and FastAPI for building the server backend. Once the project is done, I will give you a resume snippet so that you get an idea on how to add this type of learning project in your resume. One last thing before we start, PyCharm is the code editor I have been using for my Python coding for past 10 years, and the company behind this editor, JetBrains, is the sponsor of this video. As part of this collaboration, you all will get 3-month free subscription of PyCharm professional version, which is much better than the community version. I will provide more details during the video. Let's get started. Let us first discuss what kind of business problem we are trying to solve. Let's say there is this company called Coho, which builds software products such as CRM, billing system, HR software. This imaginary company, sort of like Zoho, which is a popular company that builds CRMs, sales IQ, marketing software, all kind of softwares that helps you improve the operational efficiency of your organization. Now, this company will have many clients, and all these clients will be using one or more of the software products which are offered by Coho. And all these softwares will be generating some type of logs. If you have done programming or if you're a software programmer, you would know that when you write software, you would write things into log files with some kind of log level such as warning, error, info, etc. And these log lines will contain information such as what your software code is trying to do, like retrying, or if there is an error, exception, or there is an important information you want to log, you will log all of that. Now, companies can make good use of these log files by setting up a log monitoring system so that if there are exceptions occurring or if the servers are crashing, you can have some kind of monitoring on those logs. You can generate some alarms, and based on those alarms, you can take some actions. In case of Coho, they do not have sophisticated log monitoring system. Because of that, they are running into multiple issues. The first issue is delays in detecting issues. So what happens is, let's say there is an exception, or let's say server has crashed. That is being logged into the log file, but there is no feedback or monitoring system such that alert is raised and a software programmer working at Coho gets a notification so that they take an action. They do not have that system, or even if they have the system, it is very, very basic, due to which client is complaining. And when client complains, that's when they come to know. So it is very reactive approach. It is not a proactive approach. In a mature product company, you will have proper log monitoring so that even before client detects the issue, you will come to know as an owner of that product, and you will take immediate action to resolve that issue. The second problem is when client complains that, okay, there is this problem, the programmers will go and check 100 different logs, and they will spend few hours before they actually know what exactly is the problem. If they had a better log monitoring system, they would immediately know that this application and this particular software class is having an issue, and they'll be able to resolve the problem at a faster speed. The third problem is weaker security. Maybe there is a cyber security attack, and once again, due to lack of log monitoring system, they are not able to tackle all these security problems as well. So as a solution, you need to build a log monitoring system which will aggregate all these logs, and you're building that system on top of it. And one of such systems is Splunk. There are many other softwares out there. When I was at Bloomberg, we were using a system like this. We had Splunk initially, where you see all these logs. For example, see, these are like security logs. These yellow bar, right? Like this yellow bar that you see. These are events. These are deletion. These are some cleanup logs that you see. And you have all these visualizations. Not only visualization, you will have alerts. So when I was working at Bloomberg, if there is a critical error, we will get a showstopper ticket. Okay. So this Splunk will create an alert, and that alert will create a ticket, showstopper ticket, into our system. And as part of that automation, we will get a phone call. So whoever is on call, that person will get a phone call. They will also get a text message on their phone. And because of that, you can take immediate action so that damage can be reduced. I'm showing you a couple of screenshots of Splunk. You can Google Splunk screenshot, so you will get some view or visualization of how this system looks like. Okay, so here, see, there are incident review, like the tickets or the errors that happens. So critical error, high, medium, all those errors, and those are detected based on these log monitoring system. So here you see some detailed logs, right? Like here, see all these logs that you see. So here is another screenshot. I got all these screenshots from Google. This one is, I think, from DocuSign. So you got an idea that we want to build log monitoring system. Now, before we build that, we need to build one component before the actual log monitoring system, which is log classification system. And that is the purpose of today's tutorial. We are not going to build the monitoring system because for that you need software like Splunk. Okay, we will build a log classification system. Now, if you're a programmer, you will be like, my logs already have these log levels or these log severities such as info, error, warning, debug, critical. You know, there are like different 5 or 6 severity levels or log levels. And if you look at this log level, maybe you can have some kind of regular expression such that whenever you see error, or let's say critical error, maybe for all the errors you don't want to wake up your programmer in the middle of the night, but under error, let's say if you detect some kind of pattern using a regular expression, then give a phone call to your programmer who is on the call. Okay, you can do that. See, that system works, but the log level based monitoring system is not perfect. See, sometimes programmers do not write perfect logs. When you have multiple systems, when you have legacy system, there might be too much code, too much log. And here, although application is crashing, the programmer is logging it as an info level log, which is bad. Sometimes you need these logs to be classified based on the functional category, not based on your programming log levels. Okay, for example, these 2 logs, you should be classifying them as security alerts. See, multiple login failures, abnormal system behavior. Then these logs, they talk about resource usage. I have this much total memory, used is this. That should be classified as functional category resource usage. Then you have escalation rule, fail, undefined escalation level in your CRM. That should be classified as workflow error. So having these kind of functional categories will be helpful. Let's say if you have this type of category, whenever you get some logs under resource usage category, you can forward those to your DevOps. Okay, maybe you can have a separate dashboard in Splunk which your DevOps team is monitoring. You have this user action functional category that can be used to track your usage of your software and different screens, so that you get an idea on different actions that users are taking. Or maybe you can get an idea on what is my maximum load time, you know, when my users are active. And you can have additional support staff, or you can have additional instances of your backend server so that you can support that kind of traffic. Well, I'm making some of these things up, but you get an idea. Having functional categories will result into a lot of benefits. Okay, so the purpose of this tutorial is to build a log classification system which can take input log and classify it into one of the functional categories. I'm listing 4 here. We are going to have more categories. Let's look at the technical architecture now. So first thing that our data engineering team in Coho software company will do is they will aggregate the logs. So they have aggregated these logs in Excel file. So these kind of projects are done in phases, and our MVP, minimum viable product, which is phase 1, is data engineering team has given us aggregated log in form of Excel file. And it looks something like this. It has a timestamp, it has a source, like what kind of software product is producing this log. Okay, is it a CRM, is it a billing system, is it an HR system, and so on. And you also have a target label. So you have done some manual annotation or some automated annotation to figure out what kind of label it is. Okay, so you have this supervised training data set where you have your log, right? So your log, actually just this column, is going to be X, and your target label is going to be Y. When you examine these logs, you will find some fixed patterns. For example, see, account ID with ID some number created by user some number. You will have pattern like user some number logged in or out. Now these things can be detected easily using Python regular expressions. The question, however, is our logs might be huge. You might have 1,000,000 lines in your logs. How do you exactly know what type of unique patterns you have? For that, you can use clustering. So we take this Excel file, which is an aggregated log, and we generate embeddings using, let's say, BERT, sentence transformer. You can use any embedding model. Then we use DBScan or any other clustering algorithm to cluster all these logs. Okay, so it's an unsupervised learning approach. We are not going to provide any target label because we are not trying to classify things into our target label. We are trying to classify things as per the raw text. Do you see any patterns or any groupings or any clustering? That's what we are trying to classify. So we'll use DBScan algorithm to form clusters of all our logs. And these clusters, when you examine them, you will see this kind of text, user 685 logged out, 395 logged out. And by examining these clusters, you can come up with all type of regular expressions. So when you look at all these clusters, you will be able to build these type of regular expressions. Okay, like see, regular expression like this, and so on. And once we have identified some prominent patterns, we will build a regular expression classification function. It will be a small function where you will have patterns. You will use the RE module in Python. It will be a very simple code which will take new log and it will classify that into one of the categories. Now, you will also find unknown category, the logs which do not fall into any of those patterns. For those categories, we will have further logic. We will try to find out if this category has enough training samples or not. If it doesn't have enough training samples, you will use LLM. If it has enough training samples, you will use BERT-based classification. So LLM-based classification is going to be simple. We will use Llama model in Grok Cloud. We will create a nice prompt and say, hey, can you classify this sentence into one of these categories? We can also use few short learning to guide our LLM and say that, okay, these are the samples. Okay, so look at these samples and produce your output accordingly. For BERT-based component, what we'll do is, we will take our aggregated log, which is a supervised learning data set. Okay, it has log message, it has target label X and Y. You will give that to BERT, and BERT will produce the embeddings. Okay, so the embeddings that we are producing is for this log message. And then we use logistic regression. Okay, so for this we produce these logs. So this actually, the actual X will be the embeddings and the Y will be the target label. And once you train a model, it will be able to predict on a new log that comes in, and it will tell you one of these categories. To summarize, our architecture is going to look something like this. We take input log message. First, we run it through Regex classification. If we can find valid class, valid output category, then we are lucky, because this will be a very fast, very quick approach, and we are done. Okay, here it just stops. For unknown categories, we will ask, okay, do we have enough training samples? No, then we do LLM classification. If we have enough training samples, then we do BERT-based classification. There are various benefits of this hybrid classification approach. Number one is you are optimizing cost and performance. Let's say if you use LLM for all the log messages, it is going to work, but your cost will be higher. If you are using OpenAI, you are paying per token. Okay, so your cost is higher. And that is one of the concerns that our client or any clients who is working with any services company will have. Okay, how do we minimize the cost? Then the performance, the speed at which you are inferring, okay, the speed at which you are classifying will also be fast. Because if you are in one of these categories, which you will find that in many industry scenarios, majority of the logs you can classify using Regex. And this route is very, very fast and very, very cost optimal. The second benefit is better accuracy. As I said, if it requires you to use Regex, why should you use LLM? Regex will give you better accuracy for fixed patterns. And similarly, then using BERT, LLM, using this cascading approach, you are improving the accuracy. And scalability of such system is also higher. Tomorrow, let's say your usage of log classification goes from 1,000 log classification per day to million log classification per day, and let's say 80% of the messages are regex, you will be able to scale this thing very rapidly. If all the messages, all million messages goes through LLM, then if you're using OpenAI, you have to probably increase your instances in your Microsoft Azure service, or you have to just pay extra cost and the time, you get into all those complications which will impact your scalability. So these are the three main benefits of hybrid classification. Let us explore the data set now. As I mentioned before, data engineering team worked on this log aggregation task, and they collected all these logs in form of aggregated log file. So if you look at that file, it's an Excel file. You have various columns. So the engineering team did some data cleaning and they split the log. Log will be just one single line. They split that into these columns. So there is a timestamp when the log was generated. There is a source system from which log was generated. So you'll see things like billing system, legacy CRM. You also have a modern CRM, then the actual log message. So see here, this message is about the HTTP status code and so on. And you have target labels. So if you look at this filters, you will find all these categories: critical error, deprecation warning, and so on. So let's look at some of the categories. So critical error will be something like disk failure, your application crash, something that you want to pay attention to, quick attention to. Okay, so just read through some of these logs to develop an understanding on the nature of these logs. The data set, code, everything is on GitHub. Video description has the link of that GitHub repository. If you look at the, let's say, workflow error, see there are only few logs for this category. And I can't use regular expression. I can't also use BERT for training my model because you have only few samples. Maybe for this one, we will use LLM. When I was exploring these logs, I found one other category, which is, let's say, deprecation warning. See, again, few samples, no fixed pattern. For this also, we'll use LLM, okay? Similarly, if you look at user action category, Here you see some fixed pattern, user logged in, logged out, created. Maybe for this category, we can use user action. All right, so I would encourage you to explore these logs. In order to write code, we need an IDE. So we are going to use PyCharm professional version. You can click on this first link and install this special version that they have built for data science and ML professionals. You might already have VS Code or let's say PyCharm community version, but I would suggest we use this version because of several benefits that it offers. When you click on this second link, you will be able to use this coupon code with which you get 3-month free subscription. So this is the coupon code that you will enter. Now let me talk about the features. Okay, the first most useful feature is AI assistant. So as we code, you will see how exactly this assistant will help you, but it will make you 5x more faster. When I used it, I felt like I got some Iron Man power. You write something, it will auto-complete the code. It has so many features that we will see throughout the video. And to get AI assistant, you need to click on this third link and use this particular coupon code. So check the video description. Let me talk about some special features other than AI assistant. This PyCharm professional version provides you with an integration for Jupyter. So you can write Jupyter notebook directly. Before, I think in community version, I don't think they have this support, but here you have this awesome Jupyter notebook support. Also, you have these integrations for Git, Conda, Hugging Face, etc. So your setup is pretty straightforward. You don't have to go to like 5 different places. You get everything done within this single IDE. All right, so make sure you have installed the professional version from here, and the AI assistant can be installed. I think you have to click this link and just say try it for free for 7 days, but actually you will get 1 month using this special code, and you use this redeem coupon code here. Okay, now I'm assuming you have performed all these steps. So now we are going to create our project structure. I have created this empty directory called classification logs, which I'll open from my PyCharm professional version. When you launch it, it will ask you to open a project. I will click open and then click on classification logs. Okay, all right. Now here I will create a directory called training that will store my Jupyter notebook. Okay, you can also configure Python interpreter to be Python 3.10. In training directory, let's create another directory called dataset where I will copy my CSV file. Okay, so let me go classification logs, training, dataset, Control V. So you can see your CSV file here now. And inside training, I will create a new Jupyter notebook. So in PyCharm professional version, you can create a Jupyter notebook. Okay, so I will call it training, and let's load that CSV file into pandas data frame. Import pandas SPD. Now notice that autocomplete. That is, I think, because of the AI assistant that we have. And PD, let me increase the code. Control scroll up will increase the size of your fonts. So read CSV. Okay, here you want it to be dataset, the synthetic logs .csv, and then you can hit tab. When you hit tab, see, it will directly autocomplete that code. I have noticed that after this AI assistant, my coding speed has increased by 2 to 3x. It's very, very fast. Okay, you know what? Instead of head, I will print the entire data frame. So Control Enter, and it will start a Jupyter server. You see this starting Jupyter server message. Okay, started it at 8891. It has loaded your data frame. And the good thing about this inbuilt data frame view is that you can navigate through all the rows. You see this arrow icon? I have total 2410 rows, and I can navigate through it. In our traditional Jupyter notebook, you will do df.head, and you will be able to print only few rows. Here you can print the entire data frame. You can also filter. See, let's say on target label, I want to see only errors. So right click and you can say set local filter and show me errors. It's sort of like Excel, you know, like Excel filter. That is also something you can do. Let's say critical errors and so on. You can also look at all your sources. So let me just clear this one. So select all that. And if you look at sources, you can sort them, by the way. Okay. And you can also set a filter here. Let's say I want to see modern CRM. See modern CRM. And there is this kind of arrow. So in first 10 rows, there are 2 entries for modern CRM and so on. You can also use AI actions and say explain data frame, and they have this inbuilt AI assistant. Okay, so if you click on that, see here, you can type various instructions and it will be sort of like you're talking to ChatGPT. See here, you can see the model as well, and that will help you with your coding. So now your data frame is loaded. I'm just doing df.head just to show only, let's say, let me just show you only 3 rows, okay? And here you can click on code and you can say, okay, df.source.unique, and say it shows you all the unique values of source. So we have total these many system from which our logs are coming. Then I will do df.targetlabel.unique. See, it identifies that in the previous line you wrote unique. So it's kind of trying to autocomplete that. Once you use it, you will realize like your coding becomes really fast with this. Okay, so these many values you have for your target label and so on. Now I want to examine some of the log messages to find out on which log messages I can use regular expression. Okay. Now that can happen if you have a business knowledge and your business manager is saying that, or let's say this is related to programming. So a senior programmer who has been involved with this system will say that the user messages will have these type of pattern. Okay. So that is one way of finding patterns, like talking to someone, but programmatically also you can find out all different patterns where you can use regular expression. Okay. Now, before we do this programmatically, let me show you a way using Excel. So in CSV, okay, if you have this filters set on your columns, just by looking at these values, you can identify some pattern. See, because it will sort those values. So account ID, this, see. This is one pattern, this is second pattern, and so on. But one issue that you will face here is this. See, okay, let me just show you. I had a filter previously set, so I removed the filter. Okay, so you can see some patterns here, but this log file can have million lines. And with million lines, your Excel will struggle. You know, sometimes it takes so much time for Excel to open. So working with Excel with a lot of rows is going to be challenging. So we definitely need a programmatic way of finding the patterns for regular expressions. And that programmatic way is to use clustering. So you might have heard about this k-means, DBScan, all those clustering techniques. So let me just show you some small snippet. So this is a video from my AI bootcamp where I have explained DBScan in detail. But let me give you a brief overview. In DBScan, what you do is, for a given log message, you first generate embedding. And embedding is a number, it's a vector in n-dimensional space. Here I'm showing you 2 dimension, okay? So just assume that one dot is the embedding for one log message. Then you will have this parameter called EPS, okay, epsilon. And you will set some value, it's a hyperparameter. And you start with some data point and you try to find the core point, okay, and minimum samples. So let's say if minimum samples is 5 for any data point. And in that circle, if you find another 5 points at minimum, then that is marked as a core point, like green. Similarly, there is a logic for border point and so on. And then you can say that all these green points are in one cluster. They are kind of near to each other. In case of log message embedding, we will be using cosine distance. So if you don't know about cosine, go to YouTube, Code Basics Cosine. I have videos on that. If you don't know about, let's say, regular expression, don't worry. Just say Python regex. You will find videos on that. But the idea here is using DBScan, you will try to cluster all your log messages. So you will find all these different clusters. And when you look at the text inside those clusters, you will be able to find those regular expression patterns. Now here, I can use AI assistant. So I will click on this AI and I see it says ask the assistant to create code for you. So I will say write code to cluster log messages using DBScan, and it will just do it for you. Okay, now see here it is using a TF-IDF vectorizer. I want to use embedding, so I will just say discard, and I will say that write code to cluster log message using DBScan, use sentence transformer to generate embeddings. Now look at that, say accept. Now someone will say, okay, is it good to use these AI assistant? Absolutely. It will increase your productivity. Before this AI assistant, we had Stack Overflow, Google. And if you look at programmers, they don't remember all this code syntax. They use Google Stack Overflow. AI assistant is one next step in that evolution. You need to obviously understand the code it generates. You should not blindly accept the code and deploy it to production. Otherwise, you will run into a trouble because it's not always perfect. But at least boilerplate code, whatever minimum is required, it is generating. Okay. So here we are using sentence transformers. So let me show you sentence transformer here. So if you Google sentence transformer, it is just an embedding technique, folks. And if you don't know about embedding, you can just say code basics word embedding. I have a variety of videos on these topics. Okay, so I've explained how word embedding captures the meaning of a sentence. Okay, so if you look at the pre-trained models here in sentence transformer, which is a very popular library, we have list of pre-trained models. Okay, and we are going to use this mini LM L6v2. That model performs really well. I mean, it is not the best, but look at the size. It is only 80 megabyte. If you go for this base performing model, it will be little heavy. So it will download that model and your program may run little slower. So this is the model that vector databases like ChromaDB uses by default. So that's what we will use, and that's what is suggested by this AI code assistant. So here you are using that embedding model to generate the embedding for your log messages. So in your data frame, log message is just a column. When you say .toList, it will generate a list out of that column. And here you will generate the embedding. Okay. So let me create one more cell and let me just move this part here. And let's look at some of the embeddings. So let's say embeddings for first two log messages. So Control Enter. And let's see what the embedding is going to be. So see, it took 20 seconds to run this code. An embedding is nothing but it's a vector. And the size of the vector is 384. You see 384 columns. So for first two rows, okay, which is this row. For this row, this is the embedding. And embedding is, see, 384 columns. For the second row, which is this, see, email service experiencing issues with, for that sentence, the embedding is this. An embedding is nothing but a numeric representation of that text such that it captures the meaning of it. Now we will use DBScan. So DBScan we have imported from scikit-learn cluster and minimum sample 5, metric. Let's use cosine. You can use Euclidean distance as well, cosine, whatever. And you will say dbscan.predict and you will assign clusters. Once you have assigned those clusters, you will do df.head. So Control Enter. And you see, now it has assigned all these clusters. So this is 0 cluster, 0 cluster. These two are cluster 1 and so on. Now we will use AI Assistant to print log messages in some of these clusters. See, it has created all these clusters. We want to just view some values. See, here we can see some view with some values as well. Okay, so let's try that. So I will say df. So I will say, okay, I'm not gonna use AI assistant. I'll just write the code directly. So df dot cluster, let's say cluster value is 1. So for one cluster value, you see all these different values, and my attempt is to capture the regular expression patterns. So the pattern is like user logged out, so it should just show me all the user logged out messages, but it is not doing that. The reason could be these values. So maybe let me tweak these values. So epsilon, which is that circle I was showing, right? I want my check to be tight, so I will just say 2, and minimum samples I will say 1. I mean, this is something I have done trial and error and I have figured it out. Okay, so just run this code, and now let's see 1. Now see, it's little better. I mean, it's not perfect, but see, email service experienced this issue, this mail service encounter delivery glitch, and so on. Now I will use AI assistant to print some of the prominent clusters. So I will say that sort clusters by number of records in it, then print 5 log messages from those cluster that has more than 10 records in it. So essentially cluster size can be even 1, okay, but I want to print those clusters where the number of records or messages in it is more than 10. Okay, so let's say accept and run, and it has done that. So now if you notice, so cluster 0 is all, it looks little bit like not a very clear pattern, okay, but let's look at, okay, cluster 0 is this, 5 is this, cluster 11, look at this, user logged out, backup started, backup ended. So I can now create regular expressions out of this. See, for this I can create a regular expression, for this I can create a regular expression, okay, see, for this I can create it, system this, see, for this also I can create regular expression, okay. All right, so this way you'll be able to create a regular expression. Once again, go to that YouTube video and look at the code for the regular expression. But here what I'm going to do is use some of those patterns. And by the way, to write a pattern yourself, you can use this regex101.com. So let me just pull that screen here. So let's say I want to write a pattern for user logged in or logged out, right? Like that message. So where was that? This is the pattern, user logged in, user logged out. Okay, so here I will insert my test string. Okay, let me copy this, and here you have to make sure. Okay, anyway, I think that is not needed. I will try one line at a time. So if you want to capture this, you will say user, then after that you have number, so /d plus, which will capture your number, okay, and then you will say logged out. Now if you want to capture both out and in, then you will say out and in. Now what happens is, let's say this is my message, okay, even if you say in, it will capture that. You see that green, so it will still recognize that particular pattern. So use those concepts which you have learned from that YouTube video. Once again, let me just show you. So you just say Python regex, just in case if you don't know the concept. Or nowadays, you can use AI code assistant to kind of write those patterns for you as well. But at least as a programmer, you should be aware about those fundamentals. So I'll go to the next statement, and I have captured all the patterns. Okay, so these are all the patterns that I captured. I might have missed few, but the prominent ones I have captured here. And then in RE module, see, look at this AI code assistant. It's just doing that for me. I can just hit tab for pattern label in regex.items search. Search means from the log message. Okay, from the log message, if it finds that pattern, then this will return some value. It will not be none. So you will say return label. Otherwise, you can return none. Okay, so, or let me just return other just to show you, and run this code. And now I can say classify with regex. and the log message that I want to give is this. Okay, so user logged in, and when I do control enter, see, it is the user action message. If it is out, even then it will capture it. Okay, so okay, this should be, I think, case insensitive. So here I can select the code, open this AI assistant, and I will say in this function make the regex pattern matching case insensitive. I mean, I'm gonna Google it, right? I don't know the syntax for it, so I'm gonna do Google anyway. So I would rather use my assistant here. Okay, and here see, it added this re.ignore case. Okay, that is something you can accept and run. So it has accepted and run. And now when I enter it, see, now it is user action. So whether it's capital case, small case, it will match it. Okay, what happens if you give some random string? Okay, hey bro, chill, yeah. See, then it says other. So instead of other, I would just return none actually. So none means it doesn't return any value. But let's say if you have something like this, okay, so account ID, create, let's say you have some account ID, okay, by the dot star means any message. See, dot star means anything, any character. Okay, see, it is user action. So this way, this function will help you capture these prominent patterns. Now I will create a column in data frame called df regex label, df log message dot apply classify with regex. So it will apply this function classify with regex, and if it can classify this pattern, it will put this particular label in that column. Okay, so we will print then df. Okay, now check this. So see, file this uploaded by, so it has system notification, but the other log messages, they have none value. You see, they have none values. So I want to see for which rows it assigned that label. And the way you can do that is you will say df regex label is an. Okay, see, when you do is an, you will see the log messages for which there was no pattern. Now see, shard 6 replication task ended. There is no pattern like that, right? But instead of is an, if you do not null, then you will see those messages which are classified by regular expression. And see, there are total 500 rows. Okay, so if you look at our data frame, by the way, see, df.shape, it has total 2410 rows. Okay, out of that, this data frame, okay, if you look at this particular data frame, 500 rows. So total 500 rows were classified successfully by our regex classifier. So now what I'm going to do is remaining rows which were not classified, I will save it in a different data frame called df non-regex. Okay, and when I do control enter, see, 1910. And if you look at all these rows, okay, see, they have none label. Now for these rows, we will have to use either BERT or LLM. Looking at our diagram, we are done with this step. We have done regex based classification, and for the samples which are unknown, the approach we are going to follow is we'll ask a question: are there enough training samples? No, then use LLM classification, otherwise BERT. So how do we know if there are enough training samples or not? Well, one simple approach is we can programmatically do it. So we can go to our code. Okay, let's go here, use our AI assistant, and you can say that in df non-regex data frame, print those target labels, okay, target labels that has 5 or less rows. You can do that, or you can talk to your business manager. So see, when we talk to our business manager and senior programmers, they said that, you know, if the source is legacy CRM, okay, legacy CRM, then you will have very few messages. Okay, and that's based on domain knowledge. And that's what we found. We found that legacy CRM has only few messages, and there are two categories: workflow error and deprecation warning. Okay, workflow error and deprecation warning. So let me clear this filter and let me do this. So for workflow error, when I look at it, only 4 samples. For deprecation warning. Okay, deprecation warning, only 3. So for these 2, we can use the LLM for the classification, and for remaining, we can use BERT. So see here, it will just print the code, so accept and run. That it can conform to our domain understanding which we had. So now let's write code to do BERT based encoding. Now for doing BERT encoding, we can use the similar code, right? So here we can generate embedding, but before generating embedding, let me filter out all these rows. How do you filter that out? So we'll create a new data frame. Okay, so we'll just do filtering. So df dot, okay, so df dot, let's say source. Okay, so df source, you don't want it to be the legacy CRM, and here this will be this, and we don't want to do this on the original data frame, but on the data frame which has non-regex labels. Okay, and let's call it df non-legacy. I mean, if it is legacy, the data frame will be df underscore legacy. Otherwise, this is df non-legacy. And in df non-legacy, I want to print the unique values of source, and I don't see legacy CRM here. Meaning, for this, we can now use BERT for the encoding. Now we already have a model, right? The model object which we created before. So if you look at model, see, this is the same sentence transformer model we can use. Okay, so let me just, you know what, let me just copy this and go back here. Model is already created. So we are going to generate embeddings for non-legacy. Okay, for non-legacy, you convert it to list. We generate embedding. We'll just call it filtered embeddings because there is another embedding object already. So control enter. It's gonna take some time. Okay, all right, now once again, let's use AI. So here I will say using filtered embeddings as X and target label, because target label is your Y, right? Like the thing that you are trying to predict. Train a logistic regression model. Now it's going to use scikit-learn. So if you have done scikit-learn coding, it will import logistic regression. You can use naive Bayes as well, but logistic regression is something that you start with, and then you can try different models. Then you have train test split, you have label encoder. I don't know why you have label encoder. You don't need actually label encoder. So I made some modification into this because, as I say, like, this is not always perfect. Okay, so X is going to be filtered embeddings and Y is going to be target label, and you are training and testing the split, and you are creating train test split 0.3, 30% test, 70% training, logistic regression. Then you are training a model and then you are printing a classification report. So control enter. Look at this. Our model is doing pretty good. Okay, so for some categories, our recall and precision is not that high. Actually, precision is pretty high. See, 91%, 98%. In industry, when we work with clients, mostly we have seen like more than 80 is actually pretty good. Okay, so this one looks pretty darn good. Maybe because the data that I have is synthetically generated, but real life you'll get little less, but that's okay. So this model actually looks pretty good. You don't need to do further hyperparameter tuning, etc. Now folks, just in case you don't know how to train a model in sklearn or you don't have those fundamentals, I have this playlist. Okay, so see, watch this tutorial, logistic regression, or if you are part of our AI bootcamp, we have complete like tutorials on that topic. So this code, if you have gone through those fundamentals, this code should be very straightforward for you. All right, our model is trained, and now we can export that model to a file. So we will use joblib Python module to dump our model. So our model is CLF. So we will save that model into this kind of file. Now, usually this is a practice where people create this models directory to save the model. Okay, so I'm just going to call it log classifier, and let's create a directory. So here the directory will be models, and let's export it. So now when you look at the models, where is it? See, this model has this log classifier model exported in joblib format. Now we can use this model to perform prediction and inference. Now just for convenience, I'm going to move this directory outside. So see, let me just move it at this level. Okay, so refactor, and it will just change the code ... which is fine, because then I will have the app code here, and at that level it becomes easier to access that model. Our training notebook is complete. Now let's write the main code such that we can use later on FastAPI to build a backend. Okay, here at the root directory, I will create a new file called Regex processor. So we will have Regex processor, LLM processor, and BERT processor. I know we have not written LLM code yet, but it is pretty straightforward to write that. So we'll use these three. So let's call it Regex processor, or maybe processor Regex. That way we have processor Regex, processor LLM, and so on. Okay, and from our notebook, let's copy that function for classifying a regular expression. Usually what I do is I also write main function and say, look at this AI assistant. Once again, I really love it because this is like boilerplate code. And look at this. It's so intelligent actually. You saw what it just did. Actually, I was going to write something similar to this, and it already identified all these patterns, and it kind of gave me the test cases. So here, see, file.star. So it's like file, whatever, text uploaded. And I will write one more to kind of, for that case where it doesn't match anything. Okay, and let's run this code. So first one is user action, correct? See, user 1 to that is user action. Remaining all, these all are notification, system notification. And last one is none. See, last one is none. This works like a charm, right? Like, it's so good. So Regex processor is now ready. An eventual goal that I have is I will have all these files. See, processor LLM, okay, processor BERT, and we will have a final file called classify, which will classify the incoming log. So here, from processor Regex, import classify with Regex, and that will take one statement. So let me just create a bunch of logs here. See, it's so intelligent. Oh my God, I'm not doing anything. It is too smart to figure this out. Approach, and for login logs, classify with Regex. So I will write, classify function called log message, and here I will say label is this. Okay, and if label is none, then you will do classification with, let's say, other class, like the BERT or LLM. And BERT, LLM, etc. is determined based on the source that you have. So how about we write source as well? So we create a tuple here, and in that tuple, let's say modern CRM. That is my tuple. So I edited these logs and I added this source as well, because source helps us determine if you want to use LLM or not. So here we can simplify this by saying that, okay, this should take probably logs. Okay, so let me call this classify log. So that takes a log message. But here there is just a function called logs, and for source log in logs, because we will give that. Okay, so see, let me just show you here. We will just give this logs array here, and each element is a tuple which has source and the log. So you are saying source and log. Okay, and for each of the source and log you want to classify. So I will just say, okay, classify log using source and log message. Okay, you can just call it log message here, and that should return a label. Okay, so this should return a label. You get a label here, and maybe we can create an array of labels here. and we just append that and you return labels. I mean, you can do this as well, but it's a nice suggestion, but I'll just do this. Okay, so you are classifying log, each of these logs, and here you are supplying source and log message. So if, let's say, source is a legacy CRM, then you want to use the LLM. Else, what you do is you use regular expression first. And if you can classify, fine. But if you cannot classify, if label is none, then you will use BERT here, right? So that's our overall skeleton, our structure. Now we will implement all these pieces one by one. So let's look at the BERT. So LLM will worry about it later on. Okay, so for BERT, we already have processor BERT, correct? In which I will create a similar method. So processor BERT classify with BERT. And here I can say write code to classify log message using saved models. It is called models log classifier dot joblib, use sentence transformer embedding. Let's say I'm just literally testing this AI assistant to see how well it will do its job. It did a pretty decent job, so I'll just accept. And you have imported sentence transformer joblib. Then transformer model you are using to generate an embedding. That's very straightforward. And you loaded that model and you are saying dot predict. Now you need to give array because by default these scikit-learn models will take multiple records. So you're just giving one record and you are taking the first prediction, which is the 0th element in the array, and you are giving that predicted class back. Now one thing I will do here is, since we are going to call classify with BERT multiple times, I don't want to load these models every time, correct? So let's move them outside so that when this file is initiated, these models are initialized only once. We don't want to kind of initialize them again and again. So message embedding, you can keep the comments if you like to, and let's write. So I will just supply some messages which are related to BERT classification. Classify with BERT log and log label. Okay, I think we can try this out. This looks pretty good to me. Okay, let's try out. If there are any errors, we can fix later on. Okay, let's run this. See, it will take some time because it is initializing the embedding and also it is loading that saved model. Okay, perfect. Now let's see. Okay, this one is an HTTP status. So if you look at our training file, you will find out this looks good to me actually, because this is like, you know, like common sense. It is talking about HTTP status. This is also HTTP status. This one is critical error. See, system crashed. Hey bro, chill, yeah. Oh, there is a problem. See, now this statement doesn't belong to any category, so it should say unclassified or I don't know. But the way BERT model works is it knows 5 or 6 output categories and it will just classify it into one of the categories. This is a problem. We need to fix it. But let's check others. Multiple login failures, security errors. Yes, this is good. Server was restarted. Error. Okay, good. All right, so this looks good. I mean, it might make an error. It works on probabilities and any probabilistic model can make mistakes. So it's okay. I mean, but for this one, we need to do something. So what can we do? Okay, let me, you know what? I will just comment this code and I will run it only for this particular class. And I would like to examine the predicted probabilities. So probabilities. See, it is so smart. It kind of figures out my intent. So I will try to find out the probabilities. Okay, so right click, debug. And I will see that for this statement, what are the probabilities of my output classes? So I have many output classes, right? Like the error, the security alert, okay, critical error, and so on. And for this statement, I'm hoping that it will have not a single probability, which will be very high. And if you look at this, you see, that's what it is. All the probabilities are kind of weak. Usually, if you have one strong candidate, the probability will be more than 0.5. Usually it will be 0.8, 0.9. But here model is confused. It is thinking, oh, maybe it is critical error, maybe it is a security alert, maybe it's a user notification. It doesn't know. So out of this 5, it was not very clear. It's like you're showing one fruit to a child and you're saying, okay, is this banana, apple, grape, mango? And the child is, oh, 0.30% it looks like banana, 0.14% mango, 0.5% cherry. Child is confused. Okay, so we need to tackle this confusion, and the way we can do it is we can find out a maximum probability among this, and if maximum probability is greater than certain threshold, then only use that class, otherwise just say unknown class. Okay, so I will say if maximum probability is greater than 0.5, then predicted class is this. Okay, or you could have done that argmax, whatever it was suggesting. I think it was a good suggestion. See, predicted class is this. Okay, now it is suggesting this. Otherwise, just say, okay, hold on. So you will initialize this to be unknown, and then you return predicted class. Okay, so I'm just saying unclassified, so I just kind of reversed it. So less than 0.5, unclassified. Otherwise, whatever is the label, you give that. Okay, so let's stop this and I will run this again. So right click, run. So for this it should say unknown or unclassified. Okay, see, unclassified. And for remaining it should work. So let me just test the whole thing out. Okay, so uncomment. All right, so I run it and it looks good. So for the remaining one, it is predicting the right label. And for this one, it is saying unclassified. As a next step, we will implement processor LLM. We are going to use open source Llama model in Grok Cloud. Grok Cloud is this platform which allows you to use Llama model without having to download it locally. If you want to download it locally, you can use Ollama. Okay, Ollama. But this model is actually pretty big. So I suggest you use Grok Cloud only. I published a video on Llama project earlier where I have shown how to set up Grok Cloud, things like that. So just go to console.grok.com, create an account and generate the API key. It's very straightforward, common sense approach. And if you don't know, if you're looking for the exact steps, you can look at this project, okay? Code Basic Gen AI project, look at this project. I have explained things in detail. Once you have generated the API key, you will create a .env file. Okay, so let me go to my code and here I am going to create a .env file that will contain the Grok key. So if you look at that documentation, see here, go to documentation, quick start. You need to have this particular key. Okay, so either you can have your key here, like see, you can export it through that command and access it here. But the way I like to do this is in the env file, you just specify your key, right? Like your key. I'm not going to show my key because it's like a password. Once that is done, you will use this .environment module, see python.env module. Okay. So please do pip install python.env, then pip install grok, install all those necessary modules, okay? And then let me add my key here. I added my key and I have closed that file. And in processor llm.py, I will say from.env import load.env. And when you do that, it will go through that .env file and load those environment variables. So what happens now is, when you import grok, okay, and when you create this grok client, this statement will already load that particular variable and this grok will use that variable. Okay, so this part is done and let's look at the further documentation. To call the LLM, you will use this kind of code, client.chat.completion.create. Okay, so you can say grok.chat.completion.create and tab. See, AI assistant is so good. And here I'm not going to have this system prompt, just the user prompt, this much. So the model we will use is Llama 3.3 versatile. So if you look at this one, this is the model I'm using, Llama 3.370B versatile. And here we will give a prompt. Okay, so let's call it a prompt and give a prompt here. Prompt, that is your response, and then see, print this. Okay, so now let's just run it just to verify our setup. Run processor. So what is the difference between AI and ML? We are asking it to Llama 3.3. See, so that connection is established. See, it is printing that response. AI, whatever, you can read through it. Now let's create a function for classification. So I will call it classify. See, it is so smart. It figured out my intent. It's like reading my mind. This is amazing. Okay, classify with LLM and return this one. This is the label. And see, for prompt, sometimes you might have to do some iteration. So I thought about it. I did some iteration and I found that this prompt, okay, this prompt is the perfect. So we are saying classify the log message into one of these categories. For LLM, remember, we have two categories only, workflow error and deprecation warning. If you can't figure out a category, return unclassified. Don't make things up. Only return the category name, no preamble. No preamble means, you know, when you're in ChatGPT, it will say, if you ask a question and it will say, here is the answer. You know, it adds all that text before the actual answer. We are saying just return me the category, nothing else. Okay, very simple. And here, let's create name is equal to main, classify with LLM. So I created some statements, okay, and I'm giving it for classification. The first one is the workflow error. Second one, I think second one is migration, right? See, please migrate. So that should be the migration. And third one, it should say unclassified. Yes, that one. So right click, run it. See, perfect. Workflow error, deprecation warning, and unclassified. Now, this Grok client has some limitation on how many messages you can send because this is a free service, folks. But it's pretty big actually. So even if you run this code multiple times, it's gonna work. But just keep in mind, it has a limit. So at some point, if you're saying, okay, rate limit, etc., then you know what it is. And you can track that usage, I think here. So if you say metrics, right? Metrics will have all the request token. You can see the limits and API keys. And I think, yeah, this is the usage dashboard that Grok has. Okay, perfect. So this processor looks good. Now we can go to our classify.py file and finish the remaining code. Okay, so let's import those functions from processor BERT, from processor LLM, import all these methods, and then if it is a legacy CRM, then label is equal to classify with LLM, correct? And here you will say label is equal to classify with BERT. Okay, and this should be returned here. Okay, so that looks good. So if you check it, these four are from legacy CRM, so they should go through LLM. Then this should go through Regex. This is also Regex. But these set statements, like these two, they should go to BERT. Okay, let's run the code now. Now it's a hybrid classification based on the message, based on the source. It is going through one of those three routes and it is printing that label. Okay, so classified logs. Actually, you know what? I'm not printing that. So classified logs. So classified logs labels. Okay, let me print those labels. So print classified logs, right click, run. All right, my code ran. The first one, IP potential attack. It's a security alert. User logged in. Oh, this is not a security alert. So it made a mistake, looks like, for the second one. Okay, second one, it made a mistake. So user this logged in. Okay, third one is a system notification. Okay, processor, I'm just checking user logged in dot. That should be user action, right? So why is it saying security alert for that? Oh, I think it is saying that because I think I know the reason. See here, there is no user. We need to have that user pattern. See user, because if you look at regular expression, see user, okay? That was the problem. So classify.py, right click, run again. Now it is classifying it correctly. Okay, remaining are system notification. This one should be HTTP status, correct. Security error, workflow error, and deprecation warning. See, it is working like a charm. Now, one of the things that our business users want to do is you give a CSV file of source and log messages. So the same thing, but in a CSV format. And they want us to output another CSV, which has a third column that is a label. Okay. So let's work on that change. I have created this new directory called resources, and it has a taste.csv file. And this CSV file is pretty simple. See, if you look at this CSV file here, taste.csv, it's just the source and the log message. Okay. Source and log message. So let me just show you. Pretty straightforward. And we want to generate another CSV which has these two columns, but the third column will be target label. Okay. So that is what we want to do. So let's now go here and write another function called classify CSV, and I will have input file path here. So you can import, you can read it into a data frame. Okay. So import pandas as PD, and once you have a data frame, you can either do this, or you can simply, in that data frame, you will have source and log message, right? So you'll zip it and create a list and supply it here. So that way it will get an array of tuples, and the output that you get is just a list of labels, so that you can insert as a new pandas column. If you don't know all these pandas fundamentals, once again, I have a complete Python playlist on my YouTube channel, so just check that out. Once you have this data frame, you want to create an output file. Let's say output file. See, I like this suggestion. Like you can have underscore classified.csv or just output.csv. Okay. And df to CSV output file. All right. So let me comment this code out. Control / and classify CSV. Now it is in the resources. So resources taste.csv. Okay, I think that is correct, right? You are classify here. So resources and taste, and the output that you want. I have this old file, so I'm just going to remove this and I will just say that, okay, so I deleted that, and this should be, okay, let me place it in resources only, and let's run this code now. Let's run this. So same thing, folks, is just that our input and output format has changed from Python list to CSV file. Look at this. Now we have this output.csv, and if you look at it, see, we got this third column target label. So this is security alert. This is security. I mean, because you don't have user. Okay, so it's fine. And then system notification. The last one is workflow error and so on. Perfect. Our code is working okay. And now we can go ahead and create a FastAPI backend for this particular code. Let's wrap up our code by adding requirement.txt and readme. You can right click, add new file, requirement.txt. There are Python tools available which will automatically generate your requirement.txt file. If you don't want to do it, you can manually type in all the modules and their versions. So what I do is I go to, let's say, processor LLM, okay? And I will see that I'm importing these modules. So .environment, the actual Python module is python.environment. And then you can use pip freeze command to find out the version. Or you can go here and just type python.env. So in PyCharm, it will show you the version, see, 1.0.1. So that way, you list down all your modules, okay? After requirement.txt, you need to add readme.md. So right click, once again, readme.md. I generated this MD file using, once again, AI assistant. So I gave some instructions that this project is doing this XYZ things. This is the folder structure and so on. And it just generated this file. And then I made some modification. Okay, I added this architecture diagram for which I have a file in resources. See this arc.png. So this is the file I have. You can refer that file into README using this. Okay. Then I gave instructions. So see, it has this preview mode. So if you preview it, it will have all these instructions. See all this usage, etc. And that's it. And then you check in your code to GitHub. That's important. So in the GitHub now, if somebody is looking at your repository, it looks professional. It has proper folder structure, proper git ignore, readme file, requirement.txt file. And also your readme file will have like architecture diagram, proper instructions, so that let's say some potential recruiter is looking at your repository, they want to download and run your code locally. You have proper set of instructions. Okay, do this, do that. How do you use the app? Everything. Okay. So having this professional looking GitHub repository is going to be very beneficial. All right. So let's wrap this up. Okay. What is this code? Oh yeah. So in the notebook, actually, I forgot to show you few little minor things. So here in PyCharm professional version, when you run this notebook, okay, you see all these columns, right? And these columns have this option of showing column statistics. So you can click on this option and say compact statistics. So see what happens is it will show you all the statistics, which you will otherwise get it by calling df.info or statistics, etc. Here you get it. It's sort of like Power BI or Excel. You just see the summary. See 5 unique values, 4 unique values. HTTP status is 60%. So for categorical variables, you'll see the breakdown. So this statistics is kind of useful. You can see detailed statistics as well. You also have this data view. So if you go to data view, you will see this data frame separately in this particular separate view. You can do filtering and all of that. Okay, we have talked about it. So just explore these options, folks. As I said before, you're going to get 3-month free subscription, okay, of this PyCharm professional version. So check video description below, make right use of it. One other thing that I like is, I add all these headers. Let's say this one is data load. This one is clustering. This one is classification stage 1. Now see, I can collapse them. And it becomes more like a Word document where you have all the code. Also, if you click, let's say here, you will see the structure. See, you can navigate easily. You see, you're noticing it? This really makes navigation easier. Otherwise, you have a huge Jupyter notebook, which is running in a browser. You will scroll. It just wastes a lot of your time. Just in case you are not aware what FastAPI is, just go through this YouTube video. I have explained in depth what is FastAPI, how do you create backend server, and so on. To keep this particular video shorter, I'm not going to explain things in detail, but just an overview is, it is a framework that allows you to create a backend server. Okay, so you have to now create a new file called server.py, and you use AI assistant, or you just write the entire code on your own. I want to save my time for recording, so I'm just going to directly show you the code. So here, classify is an endpoint that we have. If a client is making an HTTP call, HTTP post call, see, you can have post call, get call. Once again, you need to know all these fundamentals. I don't want to go through all those here, because otherwise this tutorial will become 5 hours long. And this accepts input CSV file, okay? And you just do the same thing. So you read the CSV file, you do some validation. You need to have source and log message columns in that CSV file. If not, you throw the HTTP exception. Then you perform the classification same exact way that we did here. See, same way that we did here. And then these are some print logs. Okay, so then you can have an output file, you can save it, and you can return that file back to the client. Okay, so the code is kind of simple. It's not like nothing fancy here. So let me just run this code. So you will go to terminal, and you will run this code called uvcon server app -- reload, and it will start this backend server. And this is the address. Okay, now you can use an app called Postman. So install Postman. Once again, I have explained all these things in that YouTube video for FastAPI, but Postman is, a tool. It's a free tool which will allow you to make those calls. Okay, you can do those get and post calls. So I've created a new API request. See, this is the address, okay? 127.0.0.1.8,000, right? That's what it says, 127.0.0.1.8,000. And my call is classify. Okay, so it is classify, fine. Then you go to body. In the body, I mean, initially you will not see anything. Okay, so let me just remove this. Initially you will not see anything, but you will say click and you will say file. So this file variable is nothing but this variable. See, here we are saying file, and here you have text or file. So I will say file, and you can attach that file. So let's attach that same file. Okay, so classification logs resources test.csv. We are attaching that file here, and we just say send. See, you got the output back. So output is another CSV file which has source, log message, and the label. Look at this label, how beautiful this is. Okay, once again, this is security alert because you don't have user here. So I hope you get that point. Now in big organizations, enterprises, they create these microservices. So the backend that we created is one microservice which is doing log classification. And you might have a bigger system where there are different components, and these components will make HTTP call to our backend. So that's how it works. I mean, when we worked on this client project, that's what we did. We created an HTTP endpoint, and other callers, the clients, will just call it and they will get a classification. This format can be changed. It's up to you what kind of format. You can have CSV or you can just have a list of labels, up to you. All right, so that's the FastAPI part. Finally, I have attached a sample resume with a description of that project. You will find this resume in a video description below. So Peter Pandey is a junior data scientist, and they worked on this log classification system. Okay, so this is the description that you can add along with your GitHub link, or make some modifications as per your thoughts. You can also use ChatGPT to generate description like this. Okay, so this resume is provided. I hope you like this project, you learned something new. If you did, please share this with your friends who are also learning AI, machine learning, NLP, etc. This project, once again, gives you an experience as if you are working in a real life industry setting. Okay, all the code is given in the description. If you have any questions, there is a comment box below.